My name is Nikki Pike. I'm the developer relations lead for Coder. Justin?
Hi, thanks, Nikki. So I'm Justin Riak. I'm the deputy CTO at DX. My background's in software development. I spent a long time writing code, moved into architecture, but over the last few years, working for companies like Gradle and Cortex and now DX have really been focused on developer experience and developer productivity.
Yep. And I guess what we're here to talk about today is the partnership between Coder and DX. So, looking back, there's this visibility gap that we have with new tools. So we bring new tools in, but we don't ever measure them. I think it was the McKinsey Developer Velocity Index that came out that said that about 80% of companies invest in new tools, but only 36% measure the impact. So when we start talking about things like cloud developer environments, we want to be able to kind of back up the claims that we make about being able to improve developer experience and productivity. And Justin, that's kind of where DX comes in.
Yeah, that's right. So for those who aren't familiar, we are a software engineering intelligence tool, and we focus on high participation survey data. So I mean like 90% plus participation in these surveys, as well as gathering system metrics from dev tools like Coder and trying to correlate where we see data aligned to various parts of developer experience. I think that part of the reason that it's so challenging to measure developer experience and productivity is because there are so many different vectors that we can look at, and it's very difficult to know which metrics matter for which engineering organizations and culture. That's why it's important to be able to look at this through a lot of different lenses, and that's what DX tries to do as a platform.
Yep. And at Coder, what we do is we do cloud development environments. So if you haven't heard of a cloud development environment, what we look to do is we're trying to take what the developers use and love, their favorite tools, everything that they need to do their development efficiently, and we're wanting to put that somewhere, central. We say cloud development, but what we actually mean is we're a self-hosted service. We're not a SaaS service. So what we want to do is we put that onto public cloud, on premise. We can throw that, with us being, self-hosted, you can throw that on a home lab. So we really want to take everything that makes a developer productive, their favorite IDEs, their favorite tools, and we want to put that somewhere central. And some of the benefits that we get from that are quicker onboarding times. We get more consistent environments, and we get some security that comes along with that because we're taking all of that code that's on developers' laptops. If you got a team of 50 people, then you've got 50 chances of code leakage through a compromised laptop. And also, when you look at when a new developer comes on board, typically that takes anywhere, industry average, I think, Justin, is like 3 to 4 weeks for a developer to get their laptop, get everything set up. And today, the way that kind of works is all of that is a little bit of tribal knowledge, right? New developer comes in, they're having to talk to senior developers, they're looking on internal wikis, they're trying to figure out what binaries and things are approved. And where Coder comes in is we take all of that stuff that's been approved by the company and the enterprise, and we pre-configure an environment for them. So instead of having to wait for them to get their laptop and set all that stuff up, they're able to just jump in and start working. I mean, we've got one customer that was able to take, this down from 3 weeks to 1 hour. Imagine that, if you would. The ability for a new developer to be able to touch code within their first hour on the job, within their first day. That's not a pipe dream. It's something that Coder makes real.
Yeah, and for us, it's a very important metric as part of our efficiency metrics. So if you look at kind of how DX has put its metrics together, this is based on industry research that goes back a long time. So some of the creators of Dora, like Nicole Forsgren, and primary author of Space Framework, Margaret Ann Story, have contributed to the framework that we use for our metrics, which are the core 4 metrics, which is a distillation of Dora, Space, and some of our own DevX metrics that have come out of a number of white paper reports, as well as what we call our developer experience index. And that developer experience index is going to include vectors like the dev environment and efficiency metrics like onboarding. So for instance, we like to look at time to 10th pull request from an engineer, which tells us, by the time they've gotten to that point and we're able to actually, put in a meaningful pull request the 10th time, we're pretty well onboarded at that point. We've got the tools that we need. But to Nikki's point, we see, depending on engineering culture, this taking, 4 weeks, in some cases, 6 weeks is even a little bit conservative, depending on that engineering culture, to have somebody who are really at that point. Looks like we have our first question.
Yes. Muhammad is asking, what do you mean when you say you're not a cloud native, or you mean you don't use cloud platforms?
I think that one's for Nikki.
Yeah, I'm going to be honest and say I don't think we said that. Because what we mean by being a cloud development environment is that it's centrally hosted. So, under the covers, what we do is we use Terraform to provision these environments. You put a container up that allows you to have all the same tools and binaries. So, one of the problems that we generally see with enterprise environments, especially with large teams of developers, is the it works on my machine issue. So, one of the things that, I'd say one of the biggest problems that we see is, developer A is working on something and it doesn't work for developer B. And that's usually because of things like binary differences, dependency differences, or using a different version of a tool. By doing this centralized or this cloud development environment, we're preloading all of those tools for the developer and we're putting it behind the enterprise's security stack. So they are using it. When we do say cloud, like I said before, it doesn't necessarily mean public cloud. It could be on premise or it could be a team server, but we're hosting it central. And that's what we think I mean. I hope that answered your question. And going back to kind of what you were saying, Justin, I mean, when we take a look, so like the dev skiller report, skills report, the average time to full productivity is around 3 to 4 months. That's what they came out with their research. One of those reasons is all the things that we just talked about. The developer having to go set up, having to learn the company, what's approved, what's not approved. And we at Coder, we really kind of stress the point that we cut that time down because they're no longer having to work on environment maintenance. They're able just to go in and say, start working. Now, we usually say, time to first PR. I love the fact that you go get, time to 10th PR because I think that's a little bit better metric. Could you explain that out a little bit for us?
Yeah, again, so when we look at, I want to be clear too that in the course of this conversation and just in the overall understanding of developer productivity and experience, that we do not ever focus on one single metric, and we also try really hard not to focus on the individual output metrics. I think for anyone who's taken a look at this space, there are a lot of good reasons to focus on team output metrics, and so when we're looking at time to 10th PR, we're taking that as an average across engineers working on a single team or within a single organization. So how long on average does it take for an engineer to make it to 10th PR? And what we've really learned looking sort of academically at this problem and is that we have to look at, and this is not my quote, this is from the Space Framework authors, but I think it's brilliant. We have to look at a constellation of metrics operating in tension with one another so that we can really understand the way that improvements or deficiencies in one metric are going to impact other areas of developer experience and developer productivity. That's why I think, looking at a holistic solution like a CDE, which is able to roll up initial configuration and initial rollout, but also provide a smoother experience for developers while they're actually trying to get to a point of productivity and deep work is really important, right? And also I like that it's hard to be able to get metrics from an IDE that's running locally. It's difficult to determine sources of friction and bottlenecks to productivity that developers experience when that IDE is being hosted on a laptop, right? I mean, there's a lot of good reasons not to be too invasive from the data that we're pulling off of an individual developer's laptop. But when we can see how multiple experiences for an entire team are linked together using something like a hosted developer environment like Coder, then we can aggregate this stuff in a way that's more psychologically safe. And so, in that ways, we can get more accurate data, but we can also really get a snapshot of overall team productivity. So, it's not just enough to look at onboarding time to 10th PR. We need to look at obviously what impact what impact is the developer having? Like we have to be able to correlate, okay, time to 10th PR, but were those 10 PRs just update to the README file? or was that developer actually working on solving new problems and new challenges for the business? So that's why to us, the PR throughput, diffs per engineer, like these are important metrics, but they don't stand alone on their own. You have to look at how they correlate and can be cross-referenced to other productivity metrics to get a real picture where people aren't going to be able to game the system or where we aren't even incentivizing for the wrong impact.
Yep. And I love the fact that when we're talking about productivity, I mean, that's one of the things that usually has a lot of developers being very resistant to doing something like, a cloud development environment or remote development environment is, it causes them to change their workflow. Every developer has this notion they've got keyboard shortcuts, they've got plugins and extensions that they like. They don't want to actually have to change that workflow because that costs them time. If you go through and you just look at something like, making them learn different keyboard shortcuts, this may be an extra 2 or 3 seconds, but you add those up throughout their day, you add those up throughout their, across their team, those add up to real changes. So, one of the things that Coder that we really want to push on is that these remote development environments, the cloud development environments that we provide, still allow the developers to come in with all of those tools, their favorite IDEs that they want to use, all of their plugins, extensions, aliases that they use. We're not changing that, right? The developer is not having to change their workflow to fit the tool. The tool is actually providing them with an environment that they can keep up with their workflow. And that kind of stuff adds up. Not only does it add to the productivity of it, but also just the developer experience. And happy developers, tend to stay a little bit longer.
There's so many different dimensions that you can sort of look at this through. But there's two things that really stand out kind of in what you just said there, Nikki. The first, asking developers to spend any amount of time context switching from one task to another takes away from their ability to have deep and satisfying work. I want to stress when we think about developer productivity and we think about developer experience, we are certainly thinking about what that individual developer is going through and what they're experiencing in terms of their feedback loops and the work that they're doing. But the focus on improvement is overwhelmingly improving the systems in which those developers are working, improving the platforms, improving the IDE experience. Because if you really look at what causes the majority of context switching for developers, or what causes them to take their cognitive load and shift it to boring, keeping the lights on stuff that's not really solving new challenges, it's overwhelmingly in sources of friction that come from the underlying system itself, right? And so when we think about making these improvements, we're always thinking about how can we improve the underlying system. So it can be a little bit, for a person who hasn't dug into a lot of the study, it can seem like we're saying the wrong thing when we talk about improving developer productivity. It can seem like what we're trying to do is look for improvements at the individual level. And I mean, I'm not saying we shouldn't all always be trying to improve our craft and always be adopting, I think a mindset of continuous improvement, but that's not usually where the problems lie. Usually the problems lie in the platforms and the systems that the developers are kind of forced to work within. So.
Yep. And I didn't want to go back. I saw in chat here. So Michael Brewer, he brings up some good points. First and foremost, we should talk about when we're talking about Coder and how it provisions these environments, we do support VMs, we do support Kubernetes, as like, Docker as well. But he brought up the point about we don't support all IDEs, and that's absolutely true. It does have to be a remote enabled IDE. So something like Visual Studio proper is not going to work on this, although that's something that we can definitely look into. But if it's a remote capable IDE, we do support that. So JetBrains with JetBrain Gateway, Visual Studio Code, Jupyter Notebooks, things of that nature. So good point, Michael. Let's see if there's anything else in chat real quick. So, I guess going back and when we're talking about measuring this stuff, Justin, so according to, like the Cloud Accelerate State of DevOps, one of the things that they brought up was that consistent environments help breed better development teams. We've all experienced code works perfectly on one machine, fails on the other. We spend days trying to figure out what these environment problems are and trying to fix those. So, how does something like that get measured from a DX standpoint?
Yeah, so I think that, and there's a great foundational study here actually, which I'll post into chat. This is a white paper study. Let me make sure this is going to go out to everyone. Here we go. Which formed the foundation for a lot of the way that we have designed our measuring platform. So I think we look at everything that we measure from either a self-reported qualitative, or if you will, survey metric, or a quantitative system metric. And we think about these metrics, helping us look at various areas of the platform. For the survey metric side, we are running snapshot surveys. We recommend those to run on a quarterly period. And for those of you who may have experience trying to run engineering surveys, you know that it's really hard, right? I mean, most people do not experience a lot of success trying to sort of independently run these surveys. But what we've done to make this experience better, and I want to stress, we don't consider a survey to be effective or successful until we hit that 90% participation rate in the survey. I know a lot of folks, they feel good when they've hit 25%. That's about the highest that they can get. We found that you can't really start correlating to system metrics until you hit that more like 90% participation rate. And so we've done, I would say, sort of three things to be able to get that type of participation. First, the survey questions themselves are rigorously engineered by PhD researchers, some of the same researchers that were involved in the study that I just posted about what actually drives productivity for DevX, but also folks, like I mentioned before, like Peggy Story, Brian Hook, Nicole Forsgren. So these are people who have really taken a deep and academic approach to the way that these questions are engineered. And when you look at these questions, it's actually very interesting that when you get these high sampling rates, that you come within a margin of error to what might be considered a metric that would correlate to a system metric, right? So we found that, for instance, when you look at a metric like PR throughput, but you also that you can get a set of data coming from SCM or CI. But when you ask developers the question, I get to work on small incremental changes, sometimes, often, never, right? Within a margin of error, those numbers start to converge, right? The self-reported metrics of developers saying, yeah, I'm normally working on a good high velocity number of small and incremental changes to the system versus no, I'm working on big, huge lines of code PRs that take forever to get reviewed. We find that the metrics end up actually corresponding very similarly to the system metrics. So the way that you engineer the questions really, really matters. Before I continue down that path, it looks like we've got another question.
Yes, Michael is asking, I introduced GetDX at my company 2 years ago and last year Coder. I will imagine customers that are already using Coder and DX will benefit from this relationship without additional cost or friction.
And you'll see it in your DXI metrics in particular, right? Now, I mean, again, something like a development environment is going to impact all four of our core four metrics in one way or another. But you'll see things like improved onboarding. You'll see developers having a higher self-reported velocity and a higher change confidence, and even a greater amount of time being able to spend on focus time. So yeah, I mean, we actually have this data like in the platform, and it's part of what we'll be collaborating on. Kind of past this point is being able to show through the objective data that comes to the DX platform that in general, multiple vectors of the developer experience index are overwhelmingly improved by using something like Coder.
Yeah. And I just want to add to this. I mean, one, thanks, Michael. You've been very active on chat. I appreciate that. But the other thing is for companies that are looking at something like this is to ensure that you're really kind of taking this in bite-sized chunks, right? A lot of companies will jump in and they'll try to do everything all at once. Make sure you have a good plan for introducing, something new like Coder and introducing cloud development environments and getting your developers used to it, and then bringing in the metrics. So one of the things that we suggest is come in and get the baseline. Find a small team that's already seeing environmental challenges that's slowing them down, that's causing friction for them today. Start with a small team. Come in and use, DX's baseline survey to get some of those metrics before you even start. And then as you start rolling this out, retake and resample as you go through. And then make sure that you're using those results to plan your next iteration. People that try to go into this just full bore and jump into kind of the deep end of the pool, they're going to have some issues. But if you take it in smaller chunks and you reiterate and you see what works and what doesn't, where they're seeing, the reduction in friction versus where maybe something new might be introduced, you're going to want to take that and move forward with it. Anything
No,
you want to add on that one, Justin?
yeah, I know. I'm glad you brought up the workflow. I think we kind of just skipped into a lot of the theory of what we do, but when it comes down to this, yeah, you want to take a snapshot with these high participation rate surveys along with hooking up various metrics from parts of the platform to be able to correlate that. But this is a lot of how we're able to evaluate the ROI of particular dev tools through DX, is that we take this benchmark first, we look at the various aspects of the developer experience index where some organizations may be underperforming compared to the P50 or P75 or P90, whatever your targets are. We then are able to say, okay, well, you'll really benefit from this service or paying attention to this part of the platform or adopting a tool like Coder. And then we watch that onboard through system metric data, and we watch improvements to the experience that come through that qualitative data. So the ability to really benchmark with something third party and show like, yes, this is moving the needle. I mean, again, we know that this is hard to do, right? It's very, very difficult to get access to unadulterated data that says, yes, these dev tool investments that we've made have actually improved these parts of our experience. But that is the power of being able to combine a dev tool like Coder with an SEI platform like DX. And it looks like we've got this other question in Q&A too. Carla, is that the one that you're referring to from Charles's question?
Exactly, yes. So regarding the developer shift into maintenance work after friction, is this because of the need to complete a thing before the day runs out, or a shift in mindset? It says, I began maintaining to release friction and therefore will continue with maintenance work.
So I think, Charles, thank you for that question. I love all this interaction. I think that that we were referring to the part where we talked about having to context switch off to more of a maintenance task. I think that, yeah, it's so easy to say things like we're going to help reduce cognitive load for developers, or we're going to increase their flow state, or things like that. And like that and return time to developers. But when we say those things, like it's hard to actually understand that there is like there's a definition to this, right? It's not about reducing cognitive load, right? It's about, as much as possible, allocating cognitive load to tasks that are not just about keeping the lights on, that are interesting tasks to think about, because that then impacts a developer's ability to stay in a flow state. And there's, I'm not going to dive too much into the weeds of like what flow state is, but there's a lot of great research backed by neuroscience and cognitive psychology that can talk a lot about recent understandings that we've had about what flow state is and why it's so beneficial, not just to productivity, but overall satisfaction with the work that we're doing. But one thing we do know is that flow state does not take place in a state of low cognitive load, right? Flow state is happening when your brain is busy working on tasks that you're fairly skilled at and that are interesting to you. And, this isn't an engineering phenomena, right? I think that anybody who's worked on any semi-creative work that they enjoy and that they're relatively good at has been able to experience a true state of flow. And I think that we can all agree that that's a very satisfying way to be able to do our work. And the knock-on effect is going to be better productivity.
There's a couple of things I want to add to that. So, context switching, I think we can look at that in two different ways. One is from maintenance tasks to what we were hired to do, which is coding from the developer standpoint. And I think it was Electric AI that came out and said that most developers spend between 2 or 3 days just preparing environments for what they're going to be doing. So you look at the tools, if you're a Java developer, you're installing something like SDK man to switch between your Java versions. And it's very easy, if you're not remembering to do that, to get those switched. Having, cloud development environments that are maintained specifically for your project, that are ephemeral in nature, help with that context. You don't have to do anything on your laptop. You simply spin up another environment that's already prepared for you. So you cut that 2 or 3 days out of maintenance there. So that's one version of context switching. The other is, we also have to look at, when we're talking about this improvement in reducing load, is, we're talking a lot about developer experience here, but we also got to think about the platform engineering teams, the guys that are providing these platforms for the developers. I mean, you can have the best developer experience in the world, but if it is a pain in the neck for your platform engineering teams to upkeep, that's going to get impacted because they're going to have problems. And when we start looking at, these centralized development environments, cloud development environments, it really reduces platform engineering teams as well, which helps all the way through. So, new patches come out, a new dependency comes out that's approved by the enterprise. The platform engineers are not having to make sure that it's downloaded across 100 plus laptops. They're able to update it in one location. That's updated. All developers get it. So it really reduces that load on the platform engineering teams. And so, looking at this all the way through, how the platform engineering teams are going to divide this and how they're going to maintain it, right up to the developers who are using this and now reducing that maintenance level that they've got to do on their end. This is huge. I mean, that 2 or 3 days a week, again, spread that across your developers. That's like having 16 developers for the price of 10 right there if they're not using that time for anything other than coding.
You're so spot on there, because really, I think, we've maybe learned some habits from DevOps that have in some ways ironically separated the dev from the ops, right? And as we're moving now into this like discipline of platform engineering, I think we're learning from some of those sort of unintentional cultural schisms that were sort of created by really defining platform engineering as taking a lot of what we've learned from DevOps, understanding automation and better lines of communication and understanding of delegation of work and appreciation of throughput and things like that. But we've combined that with a focus on developer experience. And I think, and a lot of people are talking about this right now, a product management mindset as well. When we are building something for our developer teams so that we can achieve the same goals, more time spent coding, less friction in the system, shipping more features with higher quality code, right? We have many of the same goals, even if the work that we're doing is a little different. And that is another thing that I love about this pattern of the CDE, is that it's such an obvious convergence of the best parts of platform engineering with the best parts of providing a better developer experience.
Yep. And just to go back on, this is a constant improvement process. A lot of companies will come in when they do measure for a tool. They're coming in, they'll install the tool, they'll measure a couple months after, and then they don't really think about it again. They see a result that they like, but they're not coming back. I think only like 36% of organizations are regularly measuring their progress through. And when we look at that, it's the same thing of friction, friction for developers, friction for enterprises. The process to be able to measure and get those metrics back, to provide those to your management, the C-suite, to say, hey, this is what our investment, this is our return on investment on this. That's something that has to be fairly simple as well. And I do think that, one, CDEs make for a very simple to maintain and easy platform for developers to use to increase their productivity. But DX makes returning those metrics and how that's improvement and seeing where they need to go, what they need to change next, really helps keeping that continuous improvement mindset.
Yeah, to just pick back up the thread before the questions there. So I mentioned that we do, I think, a very good job of engineering the type of survey questions that we're putting in front of developers as part of these snapshots that Nikki mentioned. We also, there's 2 other parts to this. The integration, like how do you actually get the surveys in front of developers? And a lot of that is really meeting developers where they are, right? So Slack, Teams, ultimately I foresee more integration and an opportunity for more integration with things like cloud development environments. But really making sure that we aren't creating yet another context switch point for developers by asking them to provide this feedback. And that, the way the questions are engineered, that they look and feel like questions that are giving developers a voice in their experience. That, again, I just can't stress enough that these are not about stack ranking individual developers. These are not about looking at like an individual developers or even an overall team's performance. It really is making sure that developers understand that the questions that they're being asked are there to provide a foundation for better investment in their own experience, better investment in tools like Coder. And that's where that last bit of it comes in, which is, the sort of top-down and executive leadership, being able to evangelize and make sure that engineering teams understand, like, why did we decide to go to Coder? Why are we running these surveys? Like, we are doing this so that you have a better environment and a better system within the work. I mean, and this is something that, we think about a lot of this as like new research, but one of my favorite books is Peopleware based on a study called the Coding War Games, which started in the 80s, right? And we have data from this. And again, not to get too much in the weeds, just the two most important outcomes from that study were that within a single organization, there was only about a 20% differential in overall productivity of engineers, regardless of their salaries, the language they were using, with the exception of assembly, and the amount of tenure that they had. But outside of that, organizationally speaking, you had organizations that came out of that study that were 11 times as productive as the lowest performing organization. So that 21% within the single organization becomes a bit of a rounding error when you add that 11x differential across multiple organizations. But what we learned from that study was that you can build that 10x developers may be mythical, right? But that 10x organizations are very real. And the reason that those 10x organizations, 11x organizations have more performative teams is because of the investments that they've made in the underlying systems and the investments that they've made in the developer experience.
And I love, bringing up the mythical 10x developer. I mean, there's one thing that, always kind of gets left out of this. AI is becoming a portion of everything we do. It's changing the world. There's a lot of, really rabid opinions on both sides about what the impact of AI is going to be doing. And that's one of the things, with with cloud development environments, AI is going to be a part of development, right? I don't believe that AI is going to replace developers, but AI will replace developers that don't use AI. I think that's 100% true. And one of the things that we're doing, because based off of what GitHub came out of, developers that use AI assistants generally complete their task about 55% faster than they would if they didn't. So one of the things that Coder's bringing in is we're bringing in kind of a fresh take on this, rather than just having the AI assistants like Copilot or Cursor. Although we do support those, we're looking at agentic AI. So that ability to try to force multiply what the developer's doing. I mean, imagine, if you will, being able to come in and you've got an army of agents that are able to do some of the mundane tasks for you. And that's something that AI is very good at, is taking care of tasks that are very mundane, that have very set boundaries. So one of the things that we can do with that is we're bringing in agentic AI, so the developers can come in and say, you've got 5 issues in your repo. Let the AI go ahead and work on those issues for you autonomously in parallel while you're working on the next feature or release. So, basically we're making that one developer look like 4 or 5, approaching that mythical 10x developer, if you will. But we're helping them do that. But of course, they still got to have oversight from a human, because that's where the creativity comes in. That's something that AI can't do, is replace the creativity that we see through the human developer. And I think that's one of the things that would be very interesting on a measurement cycle, is what is the productivity gain when we're using something like AI and agentic AI to go in and help do that.
And Nikki and I have been fully immersed over the last couple of weeks between KubeCon, EU, and Google Cloud Next in the modern landscape of what's happening around AI, agentic AI, the possibilities of model context protocol, MCP, and agent-to-agent communication. And if I can make a prediction, I think we are moving towards the next logical architectural pattern for inference, which is going to be some sort of agent mesh. I mean, I think you're going to have something that looks a lot like a service mesh, with models as endpoints, powered probably something by like Docker Model Runner or something similar to that. So with that caveat that we've been in that world looking at what people are doing with this stuff for the last couple of weeks, I will say, somebody who's an old school developer like myself, who's writing code professionally, back in the 90s, this is a visceral change to make, to move to this. And I think, like a lot of us, I was very highly skeptical of a lot of what was happening in this landscape, especially looking at the early iterations of the technology. It didn't work very well. And I think it's very easy to kind of say, oh, well, this thing's just going to hallucinate and cause a bunch of problems. And it's just going to, cost me, it's going to delete my whole code base. And, I mean, those types of things, are happening. But the progress is marching forward, and it's marching forward at a very fast pace. DX does have a capability to measure ROI impact of investments in something like agentic AI or an AI code assistance like Copilot or Cursor. And we're finding right now that it's not evenly distributed, right? That there are engineering cultures that are clearly benefiting from this stuff, They are becoming more productive. Netflix has a lot to say on this subject. They've even come up with their own newer metrics like lines of suggested code that actually make it to production, which I think is a very interesting metric. But we have other, usually larger enterprises who are, I think, kind of struggling to see an ROI. But when we really dove into this problem, and we have a new report, DX has a new report that's coming out in less than a couple of weeks now. We're very close. It's running through design now. What we found is that you really need, like any other new introduction of technology, you really need to educate engineers on the best practices for prompting techniques. So focusing on things like meta prompting and multi-shot prompting as opposed to lazy prompting, understanding workflows like prompt chaining or recursive prompting. I don't want to call it vibe coding, but that is the technical term for it, is prompt chaining and recursive prompting and things like that, as well as understanding some of the highest value use cases. Like when we actually sampled developers who were reporting a lot of productivity gains from using AI assistants, we found that the number one most time-saving use case was stack trace analysis, right? Not even code generation. We found from our study that like the highest value use case was just having a copilot explain to you why a stack trace occurred. And so it's really interesting. This data is coming out soon, so keep an eye out for it. But I think that I've gone from skeptic to bull in a very short amount of time, seeing, we certainly still have problems with this tech. We're figuring out how to do better guardrails. We're figuring out how to implement better feedback loops to the model to try to keep things more accurate. We're learning about how determinism and non-determinism can be achieved using these models by modifying things like prompting temperature. So yeah, I think that we are going to be heading into this world. To your point, Nikki, I've heard it said a bunch of different ways over the last year. AI is not coming for your job, but somebody really good with AI might. And so I think if you're an individual engineer, you should be seeking out knowledge about the best practices and practicing trying to make the use of AI a little bit more reflexive. If you're a leader, you should be evangelizing this tech to your engineers to try to improve their odds of success professionally and in their craft.
Yep. And I think you brought up a really great point, for the fact that a lot of people and a lot of enterprises are very skeptical on AI because of that. Hey, it's going to hallucinate. It's going to mess up, delete my code base. And that is a prime reason of why Coder is doing what it's doing with agentic AI. There's really no better playground to work with agentic AI than an isolated, specifically spin up environments for this. Worst case scenario, the AI goes off the rails and does something you weren't expecting. When you look at it, you can delete the environment. You're not risking your whole code base to do this like you would be doing if you were on a local laptop. Now, sure, you can go in and branch and you can do those things, but wouldn't it just be easier if you spun this up in something that was automatically created just for that one purpose? You review that purpose. If it works, it works. If it doesn't, then you work on it, right? And I think that's one of the states that we have to remember. And then I did see a question from RG asking for a citation. And I think what you were asking for, RG, was the citation about, developers using AI assistants complete tasks 55% faster. That came from the GitHub State of the Octaverse report in 2023. So, feel free to look that up. And I see Carla's got a question.
Yes, Otavio is asking, what should I be studying? I am currently a software engineer, DevOps in Roche, and honestly, I don't like all those math and algorithms around AI. ML ops, design systems. Am I fine without studying the AI in deep, like the transformers, TensorFlow, and so on? I've been experimenting Cursor, and he has really good feedback on it.
Okay. Yeah, I've got some opinions on that, but I would say, you talked about two different things there. When we're talking about TensorFlow and things of that nature, we're talking about ML ops and we're talking about machine learning. That is one of the methods in which models get trained. That's how we go in and use AI to make AI better. There's other things that we're talking about, which are AI assistants, things like Copilot, agentic AI. Those are more natural language processes. They're using models and agents that are already out there. Now you can absolutely build your own if that's something that you want to go into, but make sure we understand the difference between how the model gets prepared versus how people use the model. And a lot of developers today, they're not getting involved in machine learning themselves. They're just using some of the AI tools that are already out there to help them, such as Cursor or Copilot. Justin?
No, you're spot on, Nikki. I mean, I think that for a software engineer, I mean, I actually find some of the nuts and bolts very interesting. I think that it's kind of interesting the way that we've sort of modeled neuronal behavior in the brain using math. When neurons have electricity that go through them because they're part of a decision process, that friction in the electricity actually causes a little bit of cellular damage, which causes the neuron to grow a tiny bit, which makes it more electrically conductive, which gives it a higher probability that electricity will flow through it on a second decision-making path. And when we look at activation functions and weights and biases, we're trying to create a crude model of the same sort of biological process, but lo and behold, it works. It can actually learn stuff and pull information out of it. So I find that stuff to be kind of fascinating, but I totally understand if you don't. And what I would really recommend as a software engineer that you pay attention to is these high value use cases, right? Learn about, I mean, prompt chaining is so powerful to be able to prompt an AI and say, hey, let's have a brainstorming session where you ask me one question at a time about this problem that I'm trying to solve. And like any of these models will take you through a whole step-by-step question and answer process, trying to poke holes in your design and getting to a specification that you can then turn around and feed into a reasoning model, which can be turned into a code specification, which then can be actually turned into code scaffolding. You are talking about saving hours of time in the brainstorming process before you've even sat down to write any code. But also, I know we all love writing documentation. That's like our favorite thing to do, right? And the AIs are actually pretty good at doing things like taking code that you've already written, adding useful comments to them, even spitting out markup in things that can be understood by like ASCII doc and LaTeX. And that can be, a way that we can save time and reduce toil in our work. You can also just have the AI explain code to you, like, oh gosh, I'm new to this framework and I want to understand, what this code in front of me is doing. The AI can help you learn and become better at your craft through doing that. So Octavia, I would recommend, no, you don't have to go and dive into the guts and learn how to use TensorFlow and learn how to train models and learn about MCP and all these things. If you want to, great, it's all there for you. That knowledge is there, and I do find it pretty fascinating. But I would focus on looking into what are the most impactful use cases, the best prompting techniques, learning why something like a multi-shot prompt is better than a lazy prompt and being able to guide the AI towards more accurate decisions. That is the kind of stuff that's going to help you right now. It's again, for me, like bitter pill to swallow sometimes because it's like, oh, I don't want this thing like doing this work for me. But we have to start, especially I think veteran software engineers, we have to start asking ourselves, like, how proud should we really be about the rote memorization of certain code patterns? Shouldn't we be, to Nikki's point, a little bit more proud of our creativity, the way that we're able to visualize a full application workflow and architecture and functional design? Those are things that you can brainstorm your way there using things like prompt chaining, but those are things that the bots are still not capable of doing for us. So it really is, you have to redefine what we think of as toil. And sometimes repeating code patterns and typing those things out, it's more and more it's becoming toil, right? So yeah, that's what I would focus on, is really learning better ways to interact with and get value from these tools.
Yeah, and I think you brought up a couple really good points there. Pair programming is something that a lot of developers are familiar with, and using AI is along that same lines. But now your pair is now virtual. But to what Justin said, there's still a lot of creativity that's missing from AI. When we look at using AI to improve developer productivity, it doesn't have to be just in the realm of code. So, let's be honest, put it out there. Most of the public models that you see, there's a little bit of a poison pill there. They've been learning both good code and bad code. So there's no, you kind of got a 50-50 shot of what you're going to get there. We can go in and talk about private AIs, training them on your code and how that can improve. But let's just look at what's already out there. The real goal here is that I go out there and I use these models, I use AI. It's not going to get everything right. It's not going to be beautiful code. I can guarantee this. But if it cuts 30% of your workload out, divide that across all your tasks. If it cuts 5% of your workload out, divide that across all your tasks. One of the things I really tell people is, again, it doesn't have to be the code base. One place where, almost everybody fails is good documentation. Everybody loves to write the code. Most people don't like to go and document. This is a use case that AI can do very, very well. with a very good set of parameters. So, not only you may still be working on your code, you may not use AI to do that, but by using AI, using agentic AI to just go in there and do that kind of documentation for you, you've effectively doubled your workload because now you're putting out good code and proper documentation so the people coming along behind you can follow you. And that's important.
And if you're a platform engineer, or if you're an engineering leader, there are, kind of like we mentioned before, there are ways to measure this, but I would also caveat, just like I always do with any of these productivity measurements, don't just look at one measurement.
Mhm.
Look at the way that these metrics impact one another. So like an example, Copilot and the API for Copilot has the ability to query the number of suggested lines of code versus the number of accepted lines of code. It's not a perfect metric, but it does show, how active engineers are with the model. It's imperfect because when you're in the VS Code or whatever you're using to interact with Copilot, you actually have to click accept to tell the API, like, yes, I just took this code that was accepted to me or was suggested to me. What's more important is to be able to correlate that to, okay, well, we think that, like Coder is reporting that X many lines of code were provided by an agent and not typed in by the developer. So we've returned to them some measure of time that we could probably extrapolate if we looked at other metrics in the organization. What's more important is that allocation metric that I mentioned before, right? Has this actually allowed developers to then turn around and spend more time on interesting tasks and new features? Mohammed brought up something that's sort of adjacent here in the chat, talking about when you're working within agile methodologies, you don't have time and flow state. But I think that another thing that we've learned from agile and certainly from DevOps is the importance of understanding our engineering team's value stream. And I think that if you look at the value stream of this of the engineering organization, and just like you've always done before, try to identify sources of friction, try to identify sources of toil, bottlenecks to productivity, and then ask yourself, would AI make this part of the workflow better? I think you will find that there are lots of opportunities, even in agile, or dare I say safe agile cultures, where you can free up a lot of this more maintenance type of work that isn't necessarily coding. I mean, I know that statistic, I think it may have come out. I think it may have been one of the McKinsey reports. I can't remember the exact citation. I'll try to look it up for follow-up. But talking about where I think it may have been actually maybe a GitLab study now that long story short, it basically sussed out that in the average enterprise, the developer is only getting about an hour a day, maybe 4 to 5 hours a week, if they're lucky, spending time actually sitting down and writing code. And so clearly then code generation is not going to be the biggest bottleneck, but find out what else it is that they're working with and see how those things can be improved using AI, using tools like Coder, and measuring the continued improvement of those things using a platform like DX.
Yeah, if you discount things like meetings, that's where we really start getting into what's affecting the developer. Because I remember the study you're talking about, and it was like 4 or 5 hours that they get to actually do coding. But we take out the 2 or 3 days that they're worried about trying to get their environment up and running. We take out, versioning differences, things of that nature. That's where we start seeing improvement. We start seeing developers starting to get more hands on keyboard and doing that time. Maybe then, Mohammed, what you're saying is you start finding more time in your day because you're taking care of some of the little things with AI. The real goal here, in my opinion, is AI is going to help turn development into something that's parallel versus serial. I don't have to work on one issue, then go to the next issue. I can work on 3 or 4 things at the same time while keeping my interest, my human development, on something that's interesting to me, the next feature, the next bug, solving business logic. That's what's going to help keep developers happy. And, the fact that we're now using agents as, virtual pair programmers, then that's what's going to help, improve their productivity without requiring extra effort from the developer. And I think that's a key point here too, is we hear a lot of things out there to say, hey, we're going to help improve your productivity, but it either makes the developer have to change the way that they're doing their workflow today, or it requires extra effort. Something like AI has the ability to put all of that on its tail and improve their productivity without having them go through and have to do a bunch of extra work to do so.
I mean,
I think
absolutely.
Carla's got another question.
Oh, looks like it.
Yes. RG is asking, another developer is asking AI to summarize the AI generated docs for them. Should docs be designed for AI consumption?
That is such an interesting question. Um, a lot of that is there's no silver bullet answer for it. It depends a lot on the culture of your engineering
Mhm.
organization, right? How documentation focused is your organization, and for organizations that focus a lot more on research versus consumer products and stuff, documentation and auditing on that level is going to be more important and probably should be more consumable. If you're providing libraries for developers to use as or APIs for developers to use as part of your what you're delivering, then I think that having a human-centric approach to the documentation is going to be important there too. What I will say though, two kind of corollaries there. First of all, a lot of these models are getting better at what we would call multi-context prompting. So the ability to feed in not typed text on keyboard, but pictures, diagrams, roadmaps, and things like
Mhm.
that as part of the prompt. And so the more visual that a lot of this documentation can be, we're finding that that the models are getting better at interpreting those visuals into workflows and roadmaps and things. One of the examples that we have in this upcoming report is using a simple decision tree, but really just prompting the model to say, okay, here's this decision tree. Now go write a React app to effectively execute this decision tree. And it's kind of very impressive how accurate the model was at generating an application that could do that. I would also say, um, regardless of whether you're the culture that's then going to try to feed documentation into an AI to try to scaffold code, get familiar with these advanced prompting techniques like meta prompting, which focuses a lot on the structure of the prompt, and multi-shot prompting, which involves actually providing example output as part of the prompt, so that the LLM is very clear on exactly how you want that output to look. So I will say, your question about should the docs be designed for AI consumption? I don't know that I would go that far for every engineering organization, but I will say that we're finding that you'll get serious gains by understanding the better prompting practices of things like meta prompting and multi-shot prompting.
Yeah, I completely agree. I mean, in my opinion, if you look at some of the AI models that are out there, OpenAI, Anthropic, I mean, these guys are literally improving on almost a daily basis. So, we look at, and when we say AI, it includes RAG, generative AI, it includes a lot of process to this. So, I think it's safe to say what may be true today may not be true next week, right? So, one of the real goals of what we're trying to see with AI RG is that they are looking to 100% make this natural language. Same thing with coding, same thing with documentation. Imagine, if you will, a day where you do development without having to ever touch an IDE. That may be possible with what we're seeing with AI. Is it there today? Absolutely not, but it's getting close when we look at some of the things that agentic AI is doing. So, should you do things specific for AI consumption? I would say, in my opinion, probably not. But to echo what Justin says, the prompting mechanisms that you use for AI make all the difference in the world. It's garbage in, garbage out. Myself, I use AI quite a bit. I use it in my job. I even use it for some of the side projects that I do coding in. I may spend a good hour, 2 hours writing a prompt to get what I want. And that's part of how to recognize what the prompt is and what the impact's going to be on AI. But the key thing here is once I get that prompt written, I can reuse that prompt. I can use it for certain, multiple other things. So it's kind of a, use once, build once, use multiple times. I'm not having to rewrite that prompt every time. I think
And I
we're going to
can't
start seeing a lot of GitHub repos just full of prompts, which, we're already starting to see that today, but really, really described prompts.
No, you're right. There are already prompt libraries that you're seeing kind of pop up around this. I also can't, if you have the ability, if you're using a model where like you're hosting the model, or you have access to temperature and system prompting, get
Mhm.
really familiar with kind of just as an extension of what Nikki just said, get familiar at building feedback loops to improve system prompts as the model starts messing things up. I mean, we aren't in a position now where we can just blindly trust these things. We may never be. I don't know. Anybody who says they know whether that's going to happen or not is lying. We this is changing so quickly. The SWE bench, SWE bench research is a great place to look for model accuracy right now. It's free. You can just go to Swebench and check it out online. And you can get an idea of the pace of progress with these things. But you do have a lot of power in terms of reusable course correction. So beyond just being able to reuse a really well-written prompt, if you find that, for instance, you're a Spring 3 shop and this thing keeps spitting out Spring 2 code, you can go into the system prompt and be like, every time you answer a Spring question, make sure that you're using Spring version 3 and not Spring version 2. And then you can change that system prompt in one place and you never have to worry about it again for your organization. And determinism the same way, setting a very low temperature will get you consistent, if not that creative output from these models. But literally, like if you set a low system temperature, like a 0.001, it's usually on a 0 to 1 scale, that's effectively governing the amount of entropy that the LLM is going to produce in its output. And so if you need more deterministic or more consistent output, setting a low temperature can get you to the point of like the same prompt resulting in the same output versus the same prompt resulting in wildly different output.
Yep. And to bring all this full circle before we turn into just an AI webinar, right? To bring all this full circle, this is where things like Coder, cloud development environments come in very handy. Again, when you're using AI, the ability to spin up an isolated, separated environment to try AI, to work with AI, where you don't have to worry about it, cross-polluting other code or harming other, developers on your team. That's where the benefit of being able to do this in something like Coder helps. And likewise, when you do start playing with this, if you follow what me and Justin were talking about, getting the baseline measurement, going in and letting some good teams go in and start working with AI and measure what their output is after that. That's going to be the information that you need. Is this for us? Is it working? Okay, it's sort of working. What do we need to improve next? And I do want to just keep continuing to caution. Remember, this measuring process, when we're bringing Coder up, you're bringing in cloud development environments, you're measuring the productivity. This is an ongoing activity that needs to happen. It's iterative. So every time you do one, you don't want to fall on your heels and say, okay, we've got something that's showing it's really good. We're just going to quit thinking about it. No, there's technology's changing faster than we can keep up with. You want to keep iterating on this. Come up with a plan to make sure that you don't get complacent in both what you're doing with your tools, but also how you're measuring the impact of those things.
Well, yeah, I mean, the nice thing is that you don't have to just blindly say, oh, okay, I think this is moving the needle. Like there are SCI tools like DX that can help you know for sure if you're really seeing benefit from these. And I think we're at the
Any
hour.
other questions out there?
Yes, we are a bit over the time, guys. So if you have any, feel free to share it with us now before it's too
Me and
late.
Justin are good at that when we start talking. And by the way,
Yeah.
for anybody, if you ever see Justin out in the wild, pull him aside, talk to him. He goes very in depth about how the brain works and what it means to us at a neurological level that is just fascinating.
Oh, thanks, Nikki. Well, and likewise, Nikki's always a great conversation. I've had so much, it's been so much fun being on the road with you these last couple of weeks and really get to not just prepare for this webinar, but get to know you and your career history and everything like that. So I would just make the same recommendation. If you get a chance to have a conversation with Nikki, you're really going to love it.
Oh, thank you very much, Charles. Appreciate that.
Great, guys. So thank you so much for the talk. It was amazing. Everyone that joined as well, remember that I will be sharing the recording tomorrow, so don't worry about that. And yeah, have a great day.